If you're a health nut, you haven't made it very far without seeing lots of information on fasting, which is just restricting the amount of food for a period of time. There's lots of different ways to fast. There's 3 day, there's 4 day, there's long-term fasting, there's intermittent fasting, there's time-restricted windows. Today we talk with Dr. Alex Moore, who is a researcher, and he specifically has 7 or 8 publications on the topic of fasting. So he himself has done some research. He is very up to date on the most current research, understanding how fasting and different forms of fasting have an impact on biological functions in the body. And there's all sorts of different forms of fasting that we kind of get into. But how does somebody figure out what is the best form for them and what is going to have the most positive impact on their body? So what we do is we go through fasting, what it's doing in the body, what the research says about it, and then we tie it all together through a vantage point of systems biology. So systems biology is the various systems within us, such as the metabolism. How is it impacting that? How is it impacting the proteins? How is it impacting the transcriptome? And we give people some pretty practical tools on how they can actually profile themselves and understand the impact of different forms of fasting. So I think the common thread through all of this is that caloric restriction is good, and avoiding lots of sugar and fats prior to bed is a good thing. But beyond that, there's a lot of different ways that it can be done. And by the way, myself and Dr. Moore have talked about leading a group of people through a 3 or a 4 day fast. Having a WhatsApp group where we can communicate with people on a regular basis. We'll bring in experts. We'll have lots of resources. Like I said, he's a researcher in this space. So if you're interested in actually going through a fast with us over the next few months, we'll do it at some point. Just comment below, because what we're trying to do is get a figure on how many people are actually interested in doing this fast with us. If we get enough interest in it, we'll do it, and we'll do it all for free. We'll get experts. We'll bring in. We'll do it up and make it a good thing. So if you are interested in doing a fast with us, just comment below something like, I'm interested in doing the fast with you. I would love to do the fast, whatever it is. It doesn't really matter. But that'll help us to gauge interest in this. So I turn it over to Dr. Moore from here.
My interest in dietary fasting, of course, because of my doctorate being in nutrition, I read a lot about it. I read a lot of the research that was coming around more recently. This is getting to be studied in humans quite a bit more. And I was just really fascinated by all the profound changes that many of these studies were finding. Oftentimes in nutrition science, when we think about diet, how someone's eating, their behavior around eating, we think about the types of foods. We're not often thinking, or at least maybe 5 or 10 years ago, not many people were talking, at least in the scientific realm, a lot about timing, where to place meals in proximity to the awake and the sleep cycle. Now we're really starting to understand just how important timing is. Of course, the contents of your diet still matters, and we'll talk a little bit about that through this presentation. But I think this is really important for everyone to understand exactly kind of what's going on with their biology over the 24-hour time block that we've established as a day in relation to diet and obviously eating. So I'm going to go over some slides. Some of this information may be a little bit basic, but I think it's very important that we just kind of set some groundwork and establish some things before we kind of dig pretty deep in a few studies that I want to highlight in this presentation today. So, I mean, it's no secret we're, in comparison to how we were living even 100 years ago, things have changed dramatically. Any grocery store is a great example of that. I mean, only until recently has food availability been predictable for humans. Knowledge of early human evolution and data from recent studies on hunter-gatherer societies that still exist suggest humans evolved in an environment where they had very intermittent access to food, and they had periods of food scarcity. So, germane really to our biology is this alteration, or this alternating between food abundance and food scarcity. And two organs that really kind of exemplify this is the liver and adipose tissue. So adipose tissue, we all know we may not like, we may not like the amount that we may have, but it serves a vital function. It's obviously storing lipid, it's storing fat for us in the event that we need to pull from that to fulfill our energy requirement. The liver serves a vital function in not only detoxifying our blood, but also being kind of the carbohydrate dispenser, keeping our blood sugar and even if we're going into a more fat oxidation state, our ketone levels up. Now, muscle tissue, depending on how much you have, can be a significant reservoir of carbohydrate and energy. But in terms of the regulation, really the focus is on liver and obviously fat. So in relation to food availability, if you're going through food scarcity, say, then obviously you're going to be in a calorie restricted state. And calorie restriction is very, very much related to this alteration between food availability and food scarcity. Research in this area is pretty well established. Everything from looking at base organisms all the way up to humans, and of course a lot of preclinical work done in rodents where you can really get deep into mechanisms. Basically, research in this area has demonstrated that you can modulate aging pathways, positively affecting age-associated diseases, and in relation to humans, a lot of really beneficial health outcomes, even down to some behavioral issues such as depression, mental clarity, things of that nature. The main issue with calorie restriction, say we're eating a normal daily diet, breakfast, lunch, and dinner, whatever your normal setup is, well, restricting, you're going to have to pull, from a meal or all your meals. Say you take 25-30% off your total calorie intake. That may be sustainable for a time, but really the issue with long-term calorie restriction, taking it on kind of like this daily basis, is compliance. A lot of people really have trouble with compliance, and of course, this can result in, particularly in obese populations, this yo-yo effect where you may lose a lot of weight on a calorie-restricted diet, but over time, your motivation, the mental aspect, it's just really hard to maintain that, and you kind of get this regain, so that you get the yo-yo effect. In many ways, intermittent fasting kind of came into vogue, at least in popular dietary culture, as a way to achieve calorie restriction, but being a little bit more amenable to compliance, meaning that you could have periods that were maybe a little bit closer to, not exactly obviously what our ancestors experienced, but you could have greater quantities of food at periods of time and then go through a restriction. So it wasn't so restrictive over such a long period of time, so it could be maintained. Now, there are many different types of intermittent fasting.
You just don't have to. I mean, the nice thing with intermittent fasting is that you don't have to be compliant every single meal. You just have to kind of check out for like the 15 hours or whatever, and then you can eat at that time. But when you're eating on a regular basis, it's more difficult to restrict yourself every single meal.
Absolutely. And something that we will get into is metabolic flexibility. So if you can train your body to be proficient at running on I'll just say simplistically, glucose, carbohydrate, and fat, you can switch between a fed and fasted state very easily, very seamlessly. If you're constantly taking in food, waking up, having breakfast, having snacks, lunch, and then having dinner, for most Americans, is actually quite late. So you're just constantly in this state of digesting food, having sugars in your bloodstream. You're not super proficient at switching between those states. And the really cool thing about intermittent fasting, at least the way that we adopt it, is having the mental clarity that comes along with it. And that's one of the features that I really like about metabolic flexibility, something that we're not going to discuss too much in this particular talk, but it is a really attractive feature. Now, there are many different ways to do intermittent fasting, and sometimes, researchers, they can get a little pedantic on terminology. Time-restricted feeding, some consider that as a distinct regimen from intermittent fasting. Just for the sake of this talk, I'm going to be using these a little bit interchangeably. I'm going to basically use intermittent fasting as an umbrella term for all the diets that you see listed below. So, basic definition, intermittent fasting is the voluntary abstinence of calorie consumption over periods of hours and or days. So we can have prolonged nightly fasting. We can have alternate day fasting, which basically you're not eating on one day and then you're eating on the next. Time-restricted eating, which this can be a little bit more flexible. And several of the studies that I'm going to highlight today used a time-restricted eating or feeding model, looking at the effects of different blocks of feeding time, whether they be earlier in the day or later in the day. There's also periodic fasting, which you may fast for longer periods of time, anywhere from, 2 to 7 days. And I know that sounds like a long time to not eat, basically. But once your body gets in a pretty metabolically flexible state, and there is a mental aspect, I will admit, there are many people that have achieved a week-long fast and more. I wouldn't recommend this type of fasting unless you are obviously under the supervision of someone that's trained this area, a physician, obviously, and you kind of know your body, your limits. The last one I'll highlight is it's called the 5-2. Basically, you're eating 5 days followed by 2 days, can be non-consecutive, of restricting calories significantly, where you may be only eating 25% of your requirements. So there's a lot of different ways to skin the cat, so to speak. But we're going to kind of place some emphasis today, as I said, on time-restricted eating. Now, what happens very basically when we look at how you're handling sugar and fat metabolism? We look at when we look at clinical labs, we generally look at blood glucose, and we can also look at ketone levels. So the higher your glucose, that generally means you're metabolizing carbohydrate. You're not metabolizing fat. You're not pulling a lot of fat out from adipose tissue or, say, other stored areas. And your ketones are going to be pretty low. Now, at the top panel, in panel A, you see what kind of happens over a 24-hour period in someone consuming a typical American diet. Those red arrows are basically showing feeding time. So you have 3 meals plus some snacks. We see these increases in blood glucose mapping to those meal events, where we see ketones just kind of staying flatlined, basically. Okay, so this is what we would expect to see in someone's normal clinical laboratories following American diet. Now, in a one-day fast, we'll see over time, if someone, say they ceased eating at around dinner time the day prior, their ketones are going to steadily rise, okay? And then they might consume something a little bit later. Then obviously glucose is entering, and we're getting this increase in glucose. So ketones and glucose are really important when we're looking at very basic metrics, and are kind of in opposition in terms of what we're seeing in the blood. Now, when someone is fasting, there's obviously important hormones to look at. There's important peptide molecules to look at. Oftentimes we are looking at leptin and adiponectin. So leptin is a hormone that's often called the satiety hormone, or even the starvation hormone. And its primary role is to regulate energy balance by inhibiting hunger. Now, the more adipose tissue you have, you can actually release more leptin, and there is such a thing as leptin resistance. and this is something that that we generally see with pretty obese people. And this is an issue because it can make losing that fat very challenging, because the signals that are dictating, how they're feeling in terms of hunger can be overwhelming. And this is kind of why we want to avoid these yo-yo type events, because it's not just looking at say markers like glucose and ketones. It's also looking at these signals that are actually affecting our drive to eat, which are very, very important. It's very easy to get really down the weeds with metabolites, metabolism, systems biology we'll talk about, but the behavioral component is absolutely fundamental, fundamental to this, fundamental to the human experience in relation to nutrition, and that's why we can talk about the most effective, quote unquote, the most effective method for, say, we want to boost ketones or we want to reduce glucose. We know how to do that pretty well, but depending on where the person is coming in relation to hormones or these molecules like leptin and adiponectin, and even their mindset, those all have to be taken into consideration.
So where would like semaglutide fit into this chart here? And then what's your opinion on using semaglutide as a weight loss modality?
Yeah, so semaglutide is a agonist of GLP-1 glucagon-like peptide. So glucagon is obviously a hormone, a peptide that we secrete. It's been used for a long time, actually in treating diabetes. And what they found, or one of the effects of it, obviously was reduction in hunger, actually slowing. One of the problematic effects with it is slowing down peristalsis, slowing down the movement of your gastrointestinal tract. So, a side effect of that, amongst other things, is you're going to have decreased hunger. So my expertise lies in the microbiome, lies in the gastrointestinal tract, gastroenterology. That's concerning for me. When you start slowing things down, you have a slower transit time because, at the end of the day, it's good to digest food, but you don't want the waste products of that digestion and absorption to be kind of hanging around and lingering. There is questions about associations with things like colon cancer, other issues such as diverticulosis, diverticulitis. The long-term effects, we're obviously going to get a lot of data on the long-term effects because so many people are taking that medication right now. Now, in terms of where that comes into the treatment process, I am not a physician, so I can't comment on individual cases. Some targeted use may be warranted for weight loss specifically. Some use may be warranted for treating what it was originally intentioned to treat, diabetes. However, I am just a little weary of long-term use and use by people that probably don't need to be using it. Meaning that they could probably get the same effect using other means, non-pharmaceutical means such as manipulating the different levers you can pull. Obviously, exercise is a great way to increase insulin sensitivity, help regulate appetite if you're not overdoing it, diet, the types of nutrients that you're taking in, and then obviously the discussion that we're having today, the timing, and manipulating that, and to actually have that work to your advantage where you're not setting yourself up. If hunger is an issue and you're using it specifically to mitigate hunger, there are ways to kind of toggle diet and timing of diet where you can reduce a lot of those cues. And also, it depends on, as I was getting into, the baseline physiology of the person. If they're leptin resistant, if they're having some behavioral issues, going the pharmaceutical route right off the bat, in my opinion, is not really warranted.
Yeah, and there's pretty open-ended access to it right now. It no longer is within just the indication of type 2 diabetes and people having this issue of leptin.
Yeah, and that's with a lot of pharmaceuticals off-label use, and like I said, a lot of people are taking it. So we will have some longer-term data here pretty soon, and we'll see. But I'm always of the opinion, if you can, take a food first, behavioral, change.
All it's doing physiologically is that you're just reducing the amount of food that you're eating, so it's eliminating that feeling that you're hungry. Correct? It's not like doing anything metabolically to lose weight. It's just restricting the amount of calories coming in. Correct?
Right. Yeah. Yep. So, I mean, if we talk about intermittent fasting, we talk about our metabolism over the 24-hour period. Of course, we have to talk about the circadian cycle, the circadian rhythm. We know that there's periods of light, there's periods of dark. Humans, we're basically, the way we're designed is we sleep during the night, we're awake during the day. So it's kind of intuitive in many ways to adopt a time-restricted eating pattern or intermittent fasting, again, using those terms interchangeably, considering these cycles. Now, organisms have evolved to restrict their activity to the night or the day by developing these endogenous circadian clocks to ensure that their physiological processes are performed at optimal times. So in mammals, the master biological clock is called the suprachiasmatic nucleus, and this is located in the hypothalamus. And the reason in the hypothalamus is it's very close to the optic nerve where you're getting light, so light is very important to kind of entrain or provide that stimuli to the brain and to set those oscillations. So as you can see, located right here in the hypothalamus. So circadian rhythms occur across a 24-hour light-dark clock cycle, and we all know that they include changes in our biology and behavior. Very basically, one that I'm sure many know about is the cortisol awakening peak, right? So cortisol peaks right when we wake up, and one of the reasons for that is to kind of get us ready, right? And then as the day progresses, it kind of goes down to nadir. Now, in terms of other signals beyond light stimuli or dark, feeding appears to be one of the most dominant timing cues in terms of establishing rhythms in the peripheral clocks, and kind of acting as an important control mechanism. So if you think about, say, people that do shift work, for instance, they may be working during the night, they may be asleep during the day, kind of flip-flop from what our biology is trained to. These individuals, there's evidence that they have a dysregulation in their metabolism, and actually they're more prone to getting metabolic syndrome. So they're kind of consuming energy outside of what a normal feeding phase would be. And particularly late night eating in humans, I mean, right before you go to bed or right before you sleep, seems to be one of the major cues that kind of throws things out of whack. Just kind of putting it simplistically.
What would you consider late?
Well, it depends on when you're going to bed. Like if I'm going to bed at 10 o'clock, eating a large meal at 9:30. That's not setting you up. That's not giving you the optimal signal, right? You're going to be digesting that, particularly depending on the nutrients that you're consuming, for many hours, perhaps, into the morning, close to when you're actually going to be getting up. So I mean, there's some individuals, depending on the amount of energy that they're consuming, their entire 24-hour period could be in a postprandial state, meaning they're constantly digesting and having fats and or lipids and glucose in their bloodstream. So I mean, all those markers are constantly elevated. That would not be a good scenario. Now, in terms of looking over a 24-hour period, seeing when you can actually impact, metabolism, insulin sensitivity decreases throughout the day and into the night. So it's actually highest in the morning. So insulin is important in many ways beyond just shuttling nutrients into the cell. It actually can also impede the action of growth hormone, which occurs at a pulsatile concentration throughout the night. So that in that scenario I just gave you, that would be bad if you were looking to maximize growth hormone output, because you're basically suppressing that signal if you're having high levels of glucose in your bloodstream, and obviously parallel to that, insulin throughout the night. Meals consumed at night are associated with obviously greater postprandial glucose and insulin, and this is really exaggerated in obese individuals. And even in healthy individuals, when we run these types of studies, like a normal, and I know body mass index is a contentious metric for a lot of people because it doesn't accurately take into account lean body mass. But when you take normal BMI individuals and feed them very, very late these high fat, high carbohydrate meals, it actually increases not just glucose and insulin, but another important marker, which is glycosylated hemoglobin. So basically, sugar sticking to blood cells. This is measured. Most people know this as HbA1c, glycosylated hemoglobin. And this, when you have this elevated for long periods of time, is a good indication of your risk in actually diagnosing type 2 diabetes. So,
and this is, I mean, a lot of people eat sweets at night, so that's a pretty common thing for people to have, like, a dessert in the evening typically. And so that you're associating, I mean, if they have a substantial amount before bed, with the decreased ability to create growth factor, and then these other subsequent issues that you're talking about right now.
Absolutely. And also, it depends on the overall energy intake that you're taking in. If you're hypercaloric, meaning that you're in a surplus and you're consuming it with, say, other types of, like fats, for instance, that reaction can actually be even more exaggerated, particularly with producing greater levels of insulin. Now, when you ask, like if your doctor asks you to take a blood sample, they want everything to be normal, right? I mean, they want you to be in a normalized state, your kind of resting state. They'll ask you to fast. It's very common for not only an overnight fast, but they'll specifically say, we want you to come in 12 hours fasted before your blood draw, so we get a more accurate representation of how you normally are. So, fasting, it's interesting how this term, it used to be a little bit more charged than it is now, but I mean, it's a very common thing that everyone should be doing on a nightly basis, but because of sleep, lacking in many individuals, and individuals consuming food later into the night, they may not have that same fasting that even our ancestors a couple, 100 years ago were experiencing a lot more frequently. Now that brings me to a very interesting study that I want to highlight in relation to where you're placing your feeding window. This was a great study published by Sutton and colleagues in Cell Metabolism, and they were interested in looking at what goes on metabolically when you compare kind of a normal American eating pattern to a early time restricted feeding window. So here we kind of see the study design. So here's 7 a.m., right? And then we kind of go into the evening. So the early time-restricted group consumed in a pretty condensed window all their food up until 3 p.m. So at 3 p.m., cut off all food, going into the evening, into the night, not consuming anything. I think the way most people, if they're doing this type of time restricted feeding, where they're having a block of eating throughout the day, they're actually doing it in the opposite direction, where they're consuming food later in the evening, even in the night, and actually fasting throughout the day. And I will admit that I have been doing that for quite some time. I'm kind of adapting my strategy a little bit, because you just feel generally when you're in a fasted state, once you become a little bit more metabolically flexible, the mental acuity is definitely a benefit. We'll get to that in a little bit. The control group, they just basically ate what would be considered like the standard, eating from 7 a.m. to 7 p.m. So they're in this 12-hour feeding block. But actually, the median American feeding time is, I believe it's either 14 or 15 hours. So it's actually greater than what they were trying to do with their control here. But when they look at basic metabolic markers, glucose, interestingly, actually didn't change. There was no significant difference in the two groups' response after 5 weeks of following this diet. And by the way, there was no restriction. They kind of ate what their normal diet, or they ate, basically the amount that they would normally consume. In comparison, the insulin response greatly decreased, greatly improved on those that actually consumed the bulk of their nutrition earlier in the day, as well as their beta cell responsiveness, kind of a marker of insulin resistance. So beta cells, these are specialized cells in an organ called your pancreas that are responsible basically for producing insulin. So you want these to be very healthy, very robust, very responsive to eating. That way they're properly functioning, getting out insulin when it's needed. If it's overworked, then obviously you're going to have you're not going to have this responsive state. So from this work, and again, it was just one study, so you have to be careful with extrapolating this to broad applications. But this kind of suggested that the body was optimized in these individuals more for taking in food in the morning. Now, those are very basic metabolic markers, like we discussed at the beginning of the talk. I think where we're kind of headed with a lot of this research is better uncovering what's going on with systems biology markers. So we're talking about the genome, what you're, kind of what you're coding for in terms of what types of proteins you're going to be making, and then how this is going to express, obviously, in your metabolism. So we can look at the proteins, particularly important proteins related to the circadian rhythm, like those looked at here in this study by Z et al., published in Nature Communications in 2020, and he looked at using a similar study design, 5 weeks, people or subjects that were consuming their food earlier in the day between 6 a.m. to 3 p.m., so pretty similar to Sutton et al., to those that were consuming actually food in a later time block, something more similar to what I think most people are doing with time-restricted feeding, 11 a.m. to 8 p.m., and then a control group. And what they actually found was the early time-restricted feeding was associated with a larger, a greater increase in this particular protein called sirtuin-1. So this is a member of the sirtuin family of proteins, which basically are a group of NAD plus dependent molecules that are involved in important cellular processes, such as including aging, transcription, autophagy, inflammation, stress resistance. Generally, you want to see greater levels of this particular marker when we're doing this type of studies, because it's actually showing it's having an effect on how our circadian rhythm is functioning, and the signals that are actually coming from that particular diet. Nutrients basically being used as signal transducers, basically. So, kind of walking back from protein. So here we see protein, looking at proteins, or what's called in systems biology kind of proteomics. Obviously, you're making these proteins ultimately from the codes that you have in your cell from DNA. So in between that process, we have transcription, and then ultimately to get the proteins, we have translation. So transcription is very interesting to look at because it's kind of seeing how you're, based on your DNA, what you're actually doing in terms of turning on machinery to synthesize different types of proteins that are going to have some type of function in whatever tissue you're looking at. So there's a lot of different tissues in the body, obviously. Oftentimes studies will look at one particular tissue. In humans, this is difficult because if you're looking at anything beyond blood, you're taking biopsies. So in exercise physiology, muscle biopsies are very common. In anyone that's participated in an exercise study, they know those can be quite painful. There's liver biopsies. In my area, the microbiome, you can actually do intestinal biopsies, which is pretty invasive. So these are not common. So a lot of this work is actually done in animal models. And this really interesting study, actually recently published in Cell Metabolism in 2023, they looked at the kind of the global effect, looking at transcription across 22 different tissues throughout the body, and they had these mice follow basically a 7-week diet of either eating their normal diet, so we call that ad libitum in a research setting, or an intermittent fasting type diet. Now, it's important to note that when we take research from animals like mice, they're not following the same routine, obviously, that we would be in feeding. But again, we're getting some really interesting data from these types of studies that are exploratory and showing us where we might want to look at in humans in the future. So after the 7-week period, they, what we call politely, sacrifice the mice to harvest all their tissues over a 24-hour period, looking at changes that occur every 2 hours over that 22-hour period to see different changes in the transcriptome, oscillations from circadian rhythmicity. So what they discovered was actually pretty profound. Again, they looked at 22 different tissues. So some of the ones that I have shown here from the figure in the published article, obviously muscle, heart, lung, liver. These are pretty intuitive. But they also looked at the adrenal glands, pancreas, spleen, brown adipose tissue, which is adipose tissue that has high mitochondrial density, which we would, as humans, we would like to have more of because this is actually fat-burning fat. Unfortunately, we don't have very much of it. But very interesting to look at. It actually plays an important role in being more metabolically flexible. But getting back to the study, they discovered that this intermittent fasting or time-restricted feeding protocol profoundly impacted gene expression. Nearly 80% of the genes they looked at showed different expression or a change in the rhythm of those particular genes in at least one tissue. So what was really interesting about that is a lot of it was related to things that we generally are after in terms of whatever our goal is. If we're trying to look into slowing down aging, we're looking in maybe reducing some inflammation. A lot of the changes that they noted in all these different tissues were extremely positive in that there was reductions in inflammation, oxidative stress, the number of protein folding occurring in the right tissues at the right time. Autophagy, of course, which is something that depending on what our health goals are and what tissue we're looking at, can be really important to turn on. Now, in terms of a really important tissue, in terms of kind of exploring how we can turn on autophagy, again, comes back to the liver. And we began this talk going over the importance of the liver in kind of acting as not only, an important detoxifying agent of the body, but also in regulating metabolism. When we're in a constant state of feeding or being in a constant postprandial state, meaning that you just finished a meal, you're digesting, you're absorbing, etc., and you're in a hypercaloric state, which most people in industrialized nations are just simply consuming too much. You're really overloading this organ, and to a point where you start depositing fat. You can reach a certain threshold where your adipose tissue is just not effectively taking in fat or storing fat, and you start storing it what we call ectopically, meaning in the organs, basically in the abdomen. So you can get it in tissues beyond the liver. You can get it even in the pancreas, which can be really, really problematic in relation to diabetes. But what we call this, and the term is changing, but I'll just use the common term, non-alcoholic fatty liver disease. So we often see fatty liver disease in alcoholics because ethanol is same with fructose, is actually very easily converted into fat and stored in the liver. But when we see non-alcoholic fatty liver disease, basically the liver is storing a lot of fat, it's getting dysfunctional, and you can start to get into a state where you develop scar tissue, and you don't want to be in this state, obviously. You want this tissue to be very healthy because it's very important for being metabolically flexible, meaning you can quickly switch from, say, metabolizing carbohydrate, glucose, to oxidizing fat, and also producing ketones. So a really good way to kind of look at the functioning of the liver is to look at the metabolites that it's producing, and as well as how it's kind of handling different overload states in relation to fasting. So again, I'm bringing up another mouse study, but this was a really interesting study where they had mice either fed a high-fat diet for a period of time, so HFD, or a high-fat diet with intermittent fasting. And this is actually just some slides, some histology of liver tissue. And here you actually see a lipid droplet, so LD, lipid droplet. You see in the high-fat fed animals, they had a lot of these lipid droplets. And those that intermittent fasted, they actually had quite a decent density of these lysosomes, or lipolysosomes. So basically, these are really effective at kind of reducing the lipid droplets in the liver. And when they actually looked at central vein in the liver, you could see these lysosomes at work dumping triglycerides out of the liver into circulation to be used. So we see some really profound visual changes occurring in the liver from intermittent fasting. And when they actually looked at markers of autophagy, specific proteins like liposomal associated membrane protein 1, they saw that this was actually increased in the animals that were on the high-fat diet and intermittent fasting. And then other markers such as liposomal acid lipase. So this is basically a storage protein. So we want to see less of this when we look at this protein. Where in the high-fat animals, they had pretty high levels of this in comparison to those that were intermittent fasting. So taken together, these findings suggest that obviously these high-fat fed states, these chronically fed states, impair autophagy flux, and also the important lysosomes that are involved with the actual process of autophagy in
Would
the
you
liver.
be able to define autophagy
and
real
looking
quick?
at Yeah, very broadly, basically, it's. I kind of like to think of it as like the recycling action of the cell. It's very simplistic, but basically, in your cell, you have different organelles. You have the endoplasmic reticulum. You have things like mitochondria, Golgi apparatus. I think a lot of people are really excited about autophagy in relation to the mitochondria, called mitophagy. We have to have a unique name for all this stuff, but basically, like organelles like the mitochondria, because of their inherent role in energy metabolism and handling a lot of reactive oxygen species, have damage done to them, right? You want to make sure that all the organelles in your cell are running with integrity, and they're not damaged, because damaged organelles not only causing clutter in the cell and not operating at peak efficiency, can also secrete their own problematic signals. So autophagy, when you have a well-functioning cell metabolism, you have these different organelles like lysosomes come in and kind of remove some of those damaged organelles, some of the debris, and kind of clean out the cell. Very simplistic, but I think for what we're trying to convey, I think that's a good explanation. Now, one area that's really important when we look at the integrity of not only organelles, but the cell itself is the membrane. So we can use metabolomic analysis, specifically looking at specialized lipids. So again, science, we have to use specialized terms. We call this lipidomics. When these animals had lipidomic analysis done to the liver tissue, they actually found that phosphatidylcholine was increased. And this is a really important component of the bilipid layer of the cell membrane that really kind of gives it its integrity and making sure that it's going to be a resilient and healthy cell. So when we start seeing damage, like in the case of non-alcoholic fatty liver disease, we start seeing a change in the composition of the lipid bilayer, particularly when we see reduction in polyunsaturated fats. So one of the reasons that it's advocated that people consume higher levels of omega-3, particularly EPA, is because, and DHA to a lesser extent, is because of the roles that it plays in keeping the cell membrane very fluid, very resilient. When you start depositing other types of fats in the cell membrane, it can become more rigid, and it's going to not be able to receive signals as well and operate within the tissue matrix as it would have if it was healthier. So here we see that not only is nutrition important, obviously, for the composition of the cell membrane, but actually fasting itself can positively change the types of fats and basically cell membrane components that you're having in your cell alongside this autophagy response. Now, I think when we talk about intermittent fasting, we talk about time-restricted feeding, like in the case of several of the human studies that I went over. People are like, well, it seems like from these limited amounts of studies that pushing up a lot of the food intake earlier in the day seems like it would be better for my metabolism. From the studies that I overviewed today, that seems to be the case, although one of those studies was in pre-diabetic individuals, the other one was in healthy individuals. But we have to understand that everyone's response to any type of intervention, whether it be maybe a nutritional factor, if we're talking about changing feeding and fasting durations, the actual timing of food, or even what type of, what our marker, what we're looking at is, are we looking at blood? Are we looking at muscle tissue? What's your what's your genome? What kind of proteins are you, or what kind of proteins are you expressing? Everyone's response is going to be different. And really, you can go in to a health coach or a physician, and you can get advice based on maybe some pretty broad standard clinical markers, and you say you're getting those tests every 6 months. That may not be enough to steer you in the right direction. I think to really optimize and to understand what is going to work best for your own physiology, and I know it's not feasible for everybody, but getting more frequent global testing. And I think that's where metabolomics really shines, as we went through several of the other layers today, like proteomics and transcriptomics. Those can also be really valuable in the future to, I think, better realize a better health score if we're looking at different types of, or we're looking at global domain, overall health, or if we're looking at, say, like your liver health, for instance. So, I don't have a one size fits all solution. It kind of depends. And I would advocate that you get basically a deep molecular signature, a baseline, and then get some health informatics to understand where you kind of need to go from there and what is going to work best with your own physiology.
There are probably some things that we can apply a broad brushstroke to, I would imagine, such as like the high sugar, high fat within a couple hours before bed, maybe eliminate that. Caloric restriction at times seems to be a positive thing. So I think even without testing, you can still, read between the lines of what is the overall objective here and bring some of those into your lifestyle. So I actually, as you were going through those, I do intermittent fasting. So I don't typically eat till 5 p.m. or so on a typical day. I don't have any hard set rules. It's just the way that works out with my flow of the day. It seems to be the most convenient. And if I get hungry, I eat. But I generally don't get hungry until between 4 and 6 p.m. because I've habituated that for so long. But as you were talking, I was thinking, I definitely am eating too late. I know that, and I've known that, but to see some data behind it. And I think that's what personalized testing can do for people, is it empowers the data behind it to give the logical conclusion for you so that you can reinforce, like, yes, I should be doing this. No, I should not be doing this. And we do have the Metabolomic testing. If you guys are interested, you can go check it out at www.therio.me. And that's not the point of this discussion, is really to sell you on metabolomic testing. It's really to give you empowering information about fasting and what you can do with that. But if you do want to kick it up a notch, like I said, you can read between the lines, caloric restriction, don't eat a lot of sugar and fat right before bed or large meals in general. You'll have more growth hormone if you avoid those things, and you're less likely to develop type 2 diabetes. But if you do want to kick it up a notch, you can do metabolomic testing to get you an idea of what's happening in the liver, what's happening in the cardiovascular system, the inflammatory system, and these overall health scores like he's displaying here. Can be really helpful for informing you, not just for having the information, but also reinforcing the compliance side, that emotional side, where it's like if you have third-party data that gives you objective information about what's going to be best for you. I find that to be very empowering anyway. So, but I do kind of have a couple questions. Maybe we take, if this is the last slide, we can take the screen share off and just go through those. So my first question was about exercise during a fasted state. What are your thoughts on that? So, and this is more selfish, right? Like, I have access to a scientist, so I get to ask my questions, and we'll have open forums. Again, if you guys are interested in doing a fast with myself and Dr. Moore, I don't know how many days it would be. I think 3 full days is what we discussed. I think I mistakenly said 4 or 5 earlier, but 3 full days. We'll bring on we'll make it good. We'll bring on various experts. We'll try to do it up for you guys totally free. But if you're interested in that, just comment below like, hey, I want to do the fast with you guys or something like that. But I want to understand like exercise in a fasted state. So usually I am not eating until like I said, 4 to 6 p.m. But I do exercise pretty rigorously prior to eating, almost always. What are your thoughts on that? What would be kind of some practices you see that would be best practices in terms of balancing out this exercise and fasting state?
Yeah, it's a great question. It's actually something that I've struggled with, and it depends on what you're trying to accomplish. So if you're going strictly from, say, a longevity health perspective, first of all, if you're of that, if that's your track, you're probably not going to be doing really extreme exercise. You've probably adapted a certain protocol that is looking to optimize whatever metrics you're using, right, to kind of inform you on your health state. Now, if you're interested in performance, or say you're interested in aesthetics, then that kind of changes the discussion. For instance, we know that if you're kind of seeking muscle building, you want to turn on certain cellular machinery that definitely gets enhanced with nutritional different nutritional signals, particularly protein. Specifically the amino acid leucine, which is very potent at kind of switching on mTOR, which is important in terms of turning on some of the muscle building mechanisms, or the protein building mechanisms in muscle. Now, there's kind of ways around that where you can still get some of the benefits of fasting while not. So, say I do a pretty intense weightlifting session in the morning, and I want to have, like your setup is, Micah, where you want to have something later in the evening, having the bulk of your calories. You could, say, take in 20 grams of protein, and basically just protein with a high leucine content. You could do that as a workaround. It would probably be best just to move the training session close to when you're going to actually consume the large meal to get all the benefits of the fasting. But again, a lot of this is dictated by people's own schedule. That's another thing that has to factor into all this. If you're working and that's the only time that you can get it in, then that may be the most optimal scenario for you, where you are working early in the morning, and depending on your goals, maybe you are taking a small amount of nutrition, but not a large amount where it's completely throwing you out of this state where you can actually get back into, say, if you are producing decent amounts of ketones, you can get back into that state pretty quickly. The other part of it obviously would be something like endurance, which I like to partake in. I know full well that the running that some of the runs that I do, for instance, in the morning, they're suffering because I'm not I eat one meal a day currently. I'm not getting in the amount of fuel that would maximize performance, but I'm looking, that's not my main goal. So I may not have the fastest run times, but I'm still getting all the benefits, all the benefits of the fast, and the extra additional benefits, obviously the cardiovascular health, and then also turning on, exercise does a great job at turning on autophagy in addition to the dietary fasting. Now, if endurance exercise is, again, your primary focus, then you kind of want to manage that. One area that I don't think has been formally studied is looking at this early time-restricted feeding with morning exercise. I think there could be some really interesting findings from that, and actually I believe, while it's basically a case study, this is what Brian Johnson, basically a guy that's very interested in improving his or decreasing the aging process. I think he adopts also an early time restricted feeding setup, and he's exercising earlier in the day. So, case study is a case study. Everyone's their own case study. But I haven't seen anything that's kind of been formally published with larger sample size in this area. Now, exercise is something that I do advocate. I think taking a holistic approach, incorporating something that's endurance or aerobic in nature, cardiovascular, strength training, of course, but then also making sure that you're getting in movement in different planes of motion to make sure you're getting balance. You can get really excellent results in actually maintenance. Doing that in the morning, fasting, and consuming a larger meal at night, particularly even the protein. Your body, your body's very, very efficient at using protein, particularly large boluses of protein. Let's not say the most efficient way to maintain muscle mass or build muscle mass. For a lot of us that are more keen on health, cognition, and I guess longevity, that's okay. There's with a lot of this stuff, there's definitely going to be a trade-off.
So you talked about Brian Johnson being a case study to himself. He's an N of one, so he's trying to figure out, and I'm not necessarily saying this is an endorsement of everything he does. I don't know what he does. I've just seen him kind of like as his vampiric-like skin. But anyway,
right.
How could somebody say they wanted to identify their best path forward in being their own N of one, their own study? So kind of like Brian Johnson, figuring out what is going to be the best for my own biology. How would you use metabolomics to inform people for this? Like frequency of testing, what would they be looking at to inform them what's going to be best for them? Just kind of a little bit more practical on that end.
Yeah, once you get into the health space, once you start looking at slowing down aging, things become a little bit more complex in comparison to like, oh, I have this particular health goal, because now you don't know exactly where to look. And I think that's one of the things that it's one of the things that I noticed when I was looking at Brian Johnson's protocol. It just seems like he's just trying everything. He's just trying everything.
Yeah, a lot of trial and error.
He has
right?
the money to do it. A lot of trial and error, and he is getting clinical data. Benchmark clinical data. So that's really wonderful, and I think he's making this all open access, which is great. But from what I could tell with his protocol, he's doing a lot of different things. Now, maybe that's justified. I haven't looked too deeply into every single aspect and justification of all of his different protocols. But if you have the goal of improving health, or you just want to improve the aging process or whatever, you need to know where to look. And, our body tells us certain things. I definitely believe in listening to your body to an extent, but we can't know everything. Getting a global panel, that is just, I think, a game changer. And whatever you decide to get, it doesn't have to be metabolomics. Going in and getting a pretty broad blood panel at your physician, getting your blood chemistry, looking at things like we looked at, the really broad metrics like your fasting glucose levels, your ketone levels. I would definitely advocate, if you're going to go that route, looking at obviously things like related nutrition, vitamins. Vitamin D is really important. You're getting a really good handle on where to direct your focus, because I don't think anyone wants to be. While what Brian Johnson is doing is interesting, he basically, to me, seems like a slave to his protocol. Meaning his whole day is occupied with this grab bag of health tricks, basically. I'm much more realistic.
His job is to be healthy. It's not it's not
right.
meant to be replicable in a lot of senses, because that is his
Sure.
job.
Yeah, basically, literally his job, right? I think we have to be efficient in our health, and also going back to the behavioral aspect, we have to be honest with ourselves and what we're going to be actually able to adhere to. If I get a global metabolomics test like the one that we offer 12 health domains. Now, that is a great start, because it might direct your focus to, okay, your liver health is not optimal. This is really where you need to direct your focus. Or conversely, it could be your cardiovascular system, it could be your inflammatory response, et cetera, et cetera. That gives you a starting point. Now, if I was in a really bad state of health where all 12 health domains were at suboptimal levels, I could go Brian Johnson on it and just try to address everything 100%. But again, going back to compliance, and just being brutally honest here, the vast majority of people that they would not sustain, would not be able to sustain that, likely get burned out in some way, and basically it was a wasted effort. I'm very much of the opinion that we should find the prime target, right? Doing a global test, focusing our effort, say, on the liver, because all these systems are interconnected. If we improve our liver health, we're likely going to improve our inflammation. We're likely actually going to be improving our cardiovascular system. Same thing if we're addressing inflammation, or even another domain in our test is environmental toxins. See, what's our toxin exposure? Is it purely because the environment that we're in, or what we're taking in terms of, say, the atmosphere, the environment that we're in, the water we're drinking, the types of foods that we're eating? Are these modifiable things that can really move the needle? And then, the closer you get to optimal health, the closer you get to the ceiling of improvement, that's where things can get a bit more specialized, and you can be a lot more targeted. But I just don't think, for most people, even half of what he does, Brian Johnson does, is sustainable or even enjoyable. I mean, if your goal is to purely live longer, I guess, but I mean, there's definitely the aspect of enjoying the time that you gain, right?
Yeah, and I think he was just an example I was bringing up as like, all right, so he's using himself as a case study, not necessarily somebody to, and I can't really speak to it. Maybe it is somebody you want to emulate or not. But at any rate, it was more just about the case study and using data to inform our decisions. So you're essentially using metabolomics as a global profiling to say, like, hey, these are my pain points, and so I'm going to dig deeper into those and understand how to modify my diet and lifestyle based on those pain points, because if my liver score is low or I have a high environmental toxicity, those are going to be things that are going to be tracking with the rest of the body. So I want to address those. And so that's essentially how you're using this in the context of fasting, diet, lifestyle, et cetera, is the global profiling aspect, which the test has the 12 key health domains, understanding which one is the pain point, and then trying to get an understanding of, hey, what are the things that are causing that? And then what are my deficiencies that are not addressing this to get it to an optimal state?
Right, and normally when we talk about data science, like the more data, the better. Now, what to actually do with that data and how to interpret it and build these modules, like what we do with our Metabolomic test, that's another story. So we're casting a very wide net, we're capturing all this data, but at the end of the day, we're condensing it and we're providing very pointed recommendations, very targeted recommendations. And this is where the idea of being precise about health, being precise about your nutrition comes into play. I mean, this idea of just doing everything perfectly, like that may work for certain individuals, or doing certain types of diets, doing certain types of fasting, maybe early time fasting or early day fasting is going to be the most optimal route for you because you have problems mobilizing fat, and you really want to spark that mobilization in your liver. Or you could be highly metabolically flexible, exercising every day, and you could actually be eating over a 12-hour time period. For some people, that's perfectly fine. That's perfectly normal. But you kind of have to get this profiling done to truly understand that. And then everyone's health changes. So, it's not like we can get our genetic profile done. Okay, great, I have these genes. I'm not going to be changing my genome. My metabolism is constantly changing. So, as we age, particularly, there's going to be fundamental changes. You're not going to be reacting to the same exercise protocol. You're not going to be reacting or assimilating nutrients the same way that you did when you were younger, say in your 20s. So all this changes, and I think that really necessitates getting multiple profilings done over time. Now, what that cadence looks like is going to vary by health status, and that's again something that we've built in to our testing based on the changes that we're seeing over time and the improvements that we're seeing. We can actually provide recommendations on when you would get, you say, when should we recheck your liver? Based on the way that it's handling these nutrients. When should we retest inflammation? Are the appropriate markers coming down where more frequent testing and changes to the protocol are not warranted? So that's another aspect, and I think being very standardized with kind of what we with allopathic medicine in general, doing these yearly or bi-yearly physicals, we're missing a lot of the important changes over those time periods. More testing could be warranted for certain individuals, particularly more than twice a year.
So I want to kind of go off the subject of testing just for 1 second, and then we'll close out. But you talked about brown fat earlier, which is a subject matter I find interesting. So you mentioned that a lot of people are deficient in brown fat, which is also not making them not as metabolically flexible as they could be. So what are the things that are causing the deficiencies in brown fat? And then on the flip side of that, how could somebody increase their brown fat in order to be more metabolically flexible?
I don't think I use the word deficient. They don't have, say, as much, say, as some other types of mammals, or even actually infants have usually a little bit greater levels of brown adipose tissue. The idea of beiging or converting what we call white adipose tissue, because when you actually look at a cadaver, or you can look at meat, basically that white fat is basically the vast majority of that tissue is obviously lipid droplets storing triglyceride. There's obviously some cellular components, but it's mostly just drops of fat. Brown adipose tissue has a lot of mitochondria and is more has more vasculature, basically more capillaries, that gives it that brownish color. And that lipid droplets are much smaller, meaning that you have a surface area amenable to pulling that fat out for usage quite quickly. Now, this discussion on increasing or beiging white adipose tissue, cold exposure, there seems to be some science behind that. Fasting actually also, as well as exercise. I mean, these are all very, very basic things that you can do. There does also seem to be a genetic component to how much you can express. Those that might be adapted to colder environments, just over genetically, are going to have a greater predisposition to accumulate that versus those that are more around the equator. But it's basic lifestyle things, honestly, and the potential of that is going to vary, and that's actually something that we're very interested in looking at. And I'll be honest, our current test, while we can give some indication of mitochondrial health and obviously metabolism and fat, we can't say like at our current state like a predictive score, like, okay, you can increase brown adipose tissue by X amount. But as we start to go into other domains, particularly when we start looking at the genome's obviously one, but the transcriptome would be very revealing, and we're very excited to eventually unveil that, because that's showing changes like beiging we can capture over time.
Well, I appreciate you discussing with us about fasting. So again, if you guys that are listening to this are interested in doing a 3-day fast with Dr. Moore and myself, we'll bring on some experts. We'll figure out a way to make it very accessible. Obviously, it'll be free, and bringing other spokespeople on who can inform best practices on how to do the fast and that kind of thing. So right now, I'm just trying to get a gauge on what the interest level might be for that. So if you are interested, please do comment, because that will inform us as to, if 1 or 2 people comment, we're going to be like, I don't know if we're going to go through all the effort of setting this up for 1 or 2 people. But if we get a lot of comments, a lot of people interested, we'll definitely do that probably by summer or something like that. But yeah, thanks again, Alex. Really appreciate you jumping on, educating us on fasting. And I know you put a lot of time into that slide set, and it turned out quite spectacular. So thank you.